Stoichiometry is the measurement of quantitative relationships in chemical formulas and equations. In this experiment, stoichiometric principles will be used to obtain the appropriate equation for the reaction between metallic iron and an aqueous solution of copper 2 sulfate. This reaction produces metallic copper, which is seen precipitating as a fine red powder. This type of reaction, in which one metal displaces another from a solution of one of its salts, is known as a single displacement reaction. Iron forms two types of ions, namely iron 2+ and iron 3+. Your task is to find out which equation is consistent with the results of your experiment. If equation 1 is correct and iron 2+ is formed, the moles of copper should equal the moles of iron. If equation 2 is correct and iron 3+ is formed, we should obtain 1.5 moles of copper per mole of iron. Let's get started. Begin by massing about half a gram of iron powder onto a weigh boat. Be sure to record the exact mass of the iron powder in your lab notebook. Next, take the mass of a clean, dry beaker and record the mass in your lab notebook. Transfer the iron powder into the beaker, taking care to transfer as much of it as you possibly can. Now we're going to use a graduated cylinder to measure out about 30 milliliters of 1 molar copper solution. Be sure that when you read the volume of the copper solution, that you're at eye level and you read from the bottom of the meniscus. Record the exact volume of the copper solution in your lab notebook. Pour the 1 molar copper sulfate solution into an Erlenmeyer flask. And place on a hot plate. Turn on the hot plate and heat the copper solution gently until almost boiling. We can observe that the copper solution is almost boiling when there are small bubbles forming at the bottom of the solution and condensation forming on the sides of the Erlenmeyer flask. Slowly add the hot copper sulfate solution to the beaker containing the iron powder. Stir the solution to ensure completeness of reaction. When the reaction has ceased, allow the copper product to settle. Be sure to record any observations in your lab notebook. Once the product has settled, carefully decant the liquid from the copper. Use a graduated cylinder to measure about 10 milliliters of distilled water. Add this distilled water to the solid copper and swirl it around to wash any remaining ions from the copper. Decant the wash water from the copper after the solution has settled. Repeat this process with another wash of 10 milliliters of distilled water. Now add several milliliters of acetone to the copper. The acetone washes are important because acetone readily dissolves the water and can remove it from your solid. Swirl and allow to stand for a few moments and then decant off the acetone. Discard the acetone into a separate beaker that will be discarded into organic waste. Repeat with a second portion of acetone. Gently heat on a hot plate. Acetone has a low boiling point and can be readily evaporated from the solid. Once the copper has cooled to room temperature, take the mass and record in your lab notebook. Now we will repeat the entire process a second time. While we're waiting for the product to cool, we can dispose of our waste in the proper waste receptacles. Make sure that you find the waste receptacle that is labeled with your lab and has a list of the products to be disposed of in it. Now that our product has cooled, we can take the mass of the solid copper. Thanks for watching the Stoichiometry Lab, filmed at Oglethorpe University.